Okay, so this is just a video to get you, if you can't follow the lab tree on your own, this is just to get you started. The more you can do your own, the better, but if you need this help, of course, you're going to take it. So the problems are the same, they're initial value problems. You've got the derivative in terms of x and y, and you've got the initial value, and you want to predict what's going to happen. Well, you want to approximate solutions of the differential equation. We have two examples for this lab. Okay, we're going to use Heun's method. So Heun's method, you choose a step size, blah 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 blah. Okay, right. Figuring out Heun's method. So worksheet 1, let's say this is using the worksheet. We can solve a specific problem. We've got mass, we've got drag coefficient, measured aerodynamics, initial velocity, velocity at this time, subject to gravity and air drags. Give my solution of this. Note the role of y is paid by v while x is paid by t. Okay, and it explains where that 0.0025 comes from. I'm just going to go through this. It's fairly straightforward. It's important for me not to do too much for you. So I get a t and a v, it asks for that. It says put the t going from 0 to 20 in steps of 0.2. That really shouldn't be a problem for us. Okay, all the way down to 20. Yeah, I don't have to do that. Label column B, input the initial velocity 0. Okay. Label column C with V0, so you can do some kind of subscript, but that's fine. That's the Euler predictor. C2 may be left blank, it should be kept blank because it doesn't make any sense yet. In cell C3, write code that uses these two, that's the T0, V0 data, to give the Euler method approximation to V at this point. So, okay, so what does Euler method say? Now I'm actually not going to put in, well, I should give you something to check. So Euler method says the next V value is the previous V value, which is this, plus the step size, which is here 0.2, times the previous slope. Now the slope is the derivative, which is this 9.81 minus 0.0025 times v squared. Now it's the previous slope, so we should use the previous v value, which is still v2 squared. So that's our Euler predictor of what's going on at t equal to 0.2. In cell 3, write code that uses this, which is the previous, as well as this, which is the predicted next, to give the Heun's method approximation to v at the next point. So what should be going in here is something like equal to the previous, which is b2, plus the step size, which is 0.2, and now you're averaging two slopes. So it should be 9.81 minus 0.0025 times the previous v squared, which is b2 squared, plus the slope at the next point, which is 9.81 minus 0.0025 times, now v squared should be the predicted next v, so that would be b3. And then that's two slopes, you average them by dividing by 2. So you're looking for something like that. Look, Heun's method, the previous v value plus step size, and then add two slopes and average them out. And now you should be able to drag down your data, produce your plot. Here's a question, a technical question for you. How do you know that the terminal velocity is 62.64? Okay, now we're going to go into VBA. So now this is the framework. Define the variables, give the initial values, print the current values, calculate the next. So let's set ourselves up a little bit here. It's probably best to set up with a button, I think. Insert ActiveX. So this would be run Heun. I won't bother right now. Now, lot of people, some people are submitting work without option explicit. Option explicit, I explained why before. If you make typos, this will catch them. Very, very important. So what are the things? Define variables, give initial values, and then a big loop that does two things. It prints current values, and then it calculates next values. So this is our basic setup, okay? So we'll do that before we do anything. So we want to write a program that takes as input all these things, and, oh yeah, what's it saying here? Open up and write on paper equations 3.14 on page, what? Okay, so it just wants us to write this equation out, I think. But sure, that's okay. Right, so these are the inputs: step size, final time, drag coefficient, mass. It doesn't seem to, there's no initial velocity here because the initial velocity is given as I'm blocking it, but it's 0. So, okay, now our inputs, a good idea is to have a dashboard. Now, the way I've put this, I'll move this and have my dashboard here. So, step size H, what was the other things? Final time is T, C, and M. They're going to be my inputs. And then, okay, so one possible outline. So think about the variables that we need, right? It's the derivative of V respect to T. So V and T are there. And if we're doing Euler's method, the predictor is going to be very, very important. So we're going to have dim, certainly dBLT as double the time. Dim, dBLV as double, that's the velocity. For doing Heun's method, we need the predictor. So dim, dBLV predicted, pred as double. We might be able to write code without, actually, no, we do want that variable. What else do we need? Well, what about the H, the final time, and the C? So dim dBL H as double. And one thing to look out for, you can't do dBL big T. Watch what happens if you do dBL big T. It changes them both to big T. So you're going to want to change this maybe to FT for final time. And then you want to do dim dBL C as double. So there's some good. Now I'm just going to follow this rather than thinking out. So we got wipe the previous output. So you can do that if you want. I'm just going to copy and paste that. That's handy. But I don't want to do that. I want to do a macro recorder because I want to put in the T and the V here. Now there's a question: do I want to print the V predictor? I don't have to. I'll leave it here as an option, but you really don't have to do it. Okay, but I definitely want the T and the V. So what I want is I'm going to run this multiple times. So I'm going to write a macro recorder that will delete whatever is in here and in here as well, as it happens, and put in the labels. Okay, so we go to developer, macro recorder. This is just setup sheet. So everything we do now is going to do that. So select them. Now don't right click delete, you're going to have a problem. Just press delete on the keyboard. Put them back in again, TV, and then I won't be using it, but you can print the predictor as well. Stop the macro recorder. That button is a bit easier to see if you're in big mode there like that. And then if you go into your code, it's in the module. If you want to copy and paste this, you can. Otherwise, you do call setup sheet. And that should probably happen before anything. Call setup sheet. Okay. So that's that bit. So the important variables, okay, wipe the previous, these column A for the time, B for the velocities. The predictors might be predicted or not at all, that's up to you, but labels in row 1 did that. Prompt user for step size and the final time. Now you don't have to do that because you're using the dashboard. Okay, so yeah, something like this. Now, there's another thing saying the initial velocity. I don't think the initial velocity should go in there. You have a variable velocity. You're going to, the initial value of v is equal to 0 in this problem, and the initial value of t is in the problem is 0 as well. What else are we looking at? At some stage, it needs user-defined drag coefficient and mass. That's from the dashboard. That's the panel that's referenced. Okay, so let's help us along. Initial values. DBLT is sorted. DBLV. I'm just going to do these the other way around. DBLV predicted actually doesn't need an initial value. Like when we did it there, you can just leave it blank. You don't have to do anything there. So forget about that. I'm obviously missing the mass, so DBLM as double. You were going to take H, final time, C, and M from the dashboard. For example, say you want, say I start with a step size of 0.1, DBLH equal to cells row 2, column 5, something like that. Okay. Final time C and M similar. Now, if we're doing a loop, we're going to need a counter, and I recommend that you use the row. So int row as integer, and then that will start at 2. Int row equal to 2. Okay, think about our loop. So it's going to be loop, the printing of the current values. So you're going to use cells. Row is given by the counter. And then in column 1, you're putting DBLT. Column 2 is V. Now think about what then is happening for your Euler predictor. So you need to calculate the next t value. How do you do that? Calculate V predictor. How do you do that? Calculate V using Heun. How do you do that? And don't forget to put your counter up by 1. Go to the next thing. And you're going to, so it should be maybe do, not loop. Do all this and then loop. And then the question is, what is your condition? And last bit of important is make sure that you save before you run a new loop that you haven't tried before, because if you crash, you might lose all your work. Now, so that's basically setting that up. Yeah, so now record a macro, select all the data. I think actually what you're better off doing is just doing, I don't think you have to record that macro, just do something like that. You'll have it there. Now, the additional functionality. If you want to do this now, you should probably maybe try the finishing the rest of it first. But you could go into column D, maybe. So this would be additional. Now this would be a different V you need. So this would be dim DBLV Euler, which isn't the predictor. That would need an initial value that would be the same. DBLV Euler would start at 0. And then that you'd just be going into column maybe 4 with that. You might have to adjust what you're deleting. Euler, okay. Calculate next values, no problem. And then you could compare these two, maybe column 4 or maybe column 3, because you don't actually need to do print the predictor. So that's that. The exact solution is given by this. So what you could do is you could also print into column 5 or whatever. Now obviously you're running space. If you still have columns, still have handy columns. Now these are additional. You want to finish the thing first. If you still have handy columns, could print exact solution as well to compare, to look at your errors. Here's a question: can you derive terminal velocity? That's up to you. You could also write the system as two first-order differential equations. What the hell is that going on about? So this is if you want to bring in the distance as well. That's a different problem. Okay, so you could really do x and v. So that would be a different problem, definitely. You've probably got enough on your plate by that point already, and it's more for the next thing. And then the harder exercise. Now, the one thing to look out for in the harder exercise, it uses similars, and it's written down here. So it's going to be a similar setup. You're going to have variables x, t, step size, final time. Initial height isn't a variable. It's just the initial height. The cylinder radius, the hole radius. You have a predictor, all these different things. You just have to be careful. You can't deal with the square root of a negative number. So if the thing that is to go into the square root ever goes negative, you're going to have to do something. You can exit the sub, or if something goes negative, you can reset it to 0. You have different options there. Now, there's probably enough in you to, you've enough to do there to do that lab, so we'll finish that there.